This train has no wheels. It doesn't touch the ground. It doesn't touch the walls. It floats inside a vacuum. And right now in China, it's already hitting 623 kilometers per hour. That's faster than a Boeing 737 at cruising altitude. In 2013, Elon Musk promised the world this exact technology. He called it Hyperloop. He said it would revolutionize travel. 12 years later, America has a test track in the desert. China has a working train. So how did China build the future while the rest of the world was still talking about it?
Because if everything goes according to plan, and so far it has, by 2026, you could travel from Beijing to Shanghai in 90 minutes. That's a distance of 1,318 kilometers. Currently, the fastest train in the world does it in 4.5 hours. But here's what nobody is talking about. China isn't stopping at 623 kilometers per hour. Their target, 1,000 kilometers per hour. And their engineers say they're ahead of schedule. So what exactly is this thing? And why does it work when every Western attempt has failed?
August 12, 2013, Elon Musk publishes a 58-page white paper called Hyperloop Alpha. The idea was elegant. Put a pod in a nearly airless tube, remove friction, remove air resistance, let it glide on a cushion of air or magnets. Theoretically, you could hit 1,200 kilometers an hour, Los Angeles to San Francisco in 30 minutes. The internet went insane. Headlines everywhere. The future of travel, faster than planes. Elon does it again. But here's what actually happened. Musk open-sourced the concept. He didn't build it himself. He said someone else should do it. So companies tried. Virgin Hyperloop, Hyperloop Transportation Technologies, dozens of startups. And in 12 years, the best anyone achieved in America was a 500-meter test track and a top speed of 387 kilometers an hour. Virgin Hyperloop laid off most of its staff in 2022, pivoted to cargo only. Meanwhile, 10,000 kilometers away, China wasn't waiting for Elon. They were building.
Here's how China's system actually works, and I promise it's simpler than you think. 2 core technologies. That's it. First, maglev, short for magnetic levitation. Superconducting magnets in the train repel magnets in the track. The train floats about 10 millimeters above the surface. No contact, no friction, no wheels wearing down. The magnets are cooled to -269 degrees Celsius, just 4 degrees above absolute zero. At that temperature, electrical resistance disappears. Current flows forever. The magnets become incredibly powerful. But here's the problem. Even without wheels, there's still one thing slowing you down: air. At 600 kilometers an hour, air resistance becomes your biggest enemy. It's like trying to run through water. So China's solution? Remove the air. The train runs inside a sealed tube. Pumps extract the air, reducing pressure to near vacuum conditions. Some estimates say they've achieved pressures lower than 1% of normal atmosphere. And when you combine zero friction with near zero air resistance, you get a vehicle that can accelerate almost indefinitely. So the technology works, but technology alone doesn't explain why China succeeded. Something else is different. Let me show you the real difference. California's high-speed rail was approved in 2008. 16 years later, it's not finished. It's over budget by $80 billion. The first segment might open in 2030, maybe. China's maglev program started serious development in 2019. By 2021, they had a functional prototype hitting 600 kilometers per hour. By 2023, they had a full-scale test line. That's 4 years from concept to prototype. 4 years. 3 factors explain this. 1. Centralized decision-making. When Beijing approves a project, it happens. No decade-long environmental reviews. 2. Existing infrastructure. China already has the world's largest high-speed rail network, 42,000 kilometers. They know how to build at scale. They have the supply chains. They have the workforce. 3. National priority. China sees this as a strategic technology, not just transportation, but aerospace, military, and economic dominance. But here's what kept me up at night when I was researching this. The test results are better than the projections.
January 2024, Shanxi Province. The T-Flight high-temperature superconducting maglev test line. This is where it happened. The capsule accelerated 200 kilometers per hour, 400, 500, 623 kilometers per hour. The fastest any maglev has ever traveled in a low-vacuum tube anywhere on Earth. And here's what makes this insane. At that speed, Beijing to Shanghai, the busiest travel corridor in China, 1,318 kilometers, takes 90 minutes. Currently, the fastest option is a 4.5-hour train, or a 2-hour flight plus security plus boarding. 90 minutes, city center to city center. No airport, just arrive. But China isn't celebrating yet, because 623 kilometers per hour is just the beginning.
By 2026, the official target is 1,000 kilometers per hour. That's faster than any commercial aircraft at cruising altitude, in a train, on the ground. But here's what the Chinese engineers are really aiming for: 2,000 kilometers per hour. At that speed, Beijing to Shanghai in 40 minutes. Beijing to Guangzhou, 2,000 kilometers in 1 hour. Think about what that means. Every major city in China becomes a suburb of every other city. You live in Shanghai, work in Beijing, you have lunch in Chengdu, dinner in Hong Kong. Geography stops mattering. Now, to be fair, there are massive challenges still to solve. Cost is one. Building vacuum tubes across thousands of kilometers isn't cheap. Estimates range from $50 million to $100 million per kilometer. Safety is another. What happens if a tube loses pressure at 1,000 kilometers per hour? What about earthquakes, terrorism? These are real concerns. And China hasn't answered all of them yet, but they're building anyway, testing anyway, moving forward anyway. Which raises the uncomfortable question, what is everyone else doing?
In 2022, Virgin Hyperloop, the company that was supposed to bring Elon's vision to life, fired most of its passenger division. They pivoted to cargo, slower development, less ambitious. In Europe, the Hyperloop development company HART is still in early testing. Their best speed so far, around 100 kilometers per hour. The United States has no federal Hyperloop program, no national initiative. It's entirely private sector, and the private sector is struggling. And here's the part that should worry Western policymakers. China isn't just building this for domestic travel. The Belt and Road Initiative already includes high-speed rail connections across Asia, into Europe, into Africa. What happens when those lines can support 1,000 kilometers per hour maglev? Beijing to Moscow in a few hours. Beijing to Singapore before lunch. This isn't just transportation, it's geopolitical infrastructure. Whoever builds the fastest trains controls the connections. Elon Musk published a white paper and said someone else should build it. China didn't publish a white paper, they built it.
In 2026, maybe 2027, China will likely open the first commercial Hyperloop line in human history. Passengers will board in Beijing. They'll sit down. They'll feel almost nothing, just a gentle acceleration. 90 minutes later, they'll step off in Shanghai. No jet lag and turbulence. Elon Musk imagined this in 2013. He called it a fifth mode of transportation. He said it was relatively straightforward. He was right. It was straightforward. Just not for him. So here's what I keep thinking about. What happens to a country that dreams big but never builds? And what happens to a country that builds while everyone else is still dreaming? Maybe we're about to find out.